In this video, we're going to have a review of right angle triangles and non-right angle triangles. Before we start, let's focus on some vocabulary together. In the IB, we're expected to know the vocabulary for labeling triangles. So equilateral triangles, every single side and angle is the same. Isosceles, two sides are the same and two angles are the same. Scalene, there are no sides that are equal to each other and no angles either. And then in order to label a triangle in terms of its angles, if it's an acute triangle, every single angle is less than 90 degrees. If it's a right triangle, we have a single right angle. And if it's an obtuse triangle, we have a single angle that is bigger than 90 degrees. Now let's focus on right angle triangles. In right angle triangles, we can use these two tools in order to solve for missing sides, Pythagorean theorem, so this only works for sides, and the trig ratios, SOHCAHTOA, works for missing sides and missing angles in a right angle triangle only. So let's refresh our brains about our Pythagoras theorem. Our Pythagoras theorem, we take a right angle triangle, we label the two legs A and B, it doesn't matter which one is A or B, and then the one that really does matter is the hypotenuse must be C. And the Pythagorean theorem is a squared plus b squared is equal to c squared. So this is not in the formula booklet, but you can use this formula for any right angle triangles only. Something else that is not in the formula booklet is your trig ratios. So the acronym for this one is SOHCAHTOA. So in order to use SOHCAHTOA, you first need to make sure that you label the angle that you're interested in. And then once the angle is labeled, then you can label which one is the opposite side and therefore which one is the adjacent side. But a little reminder that we have sine of an angle is equal to the opposite side over the hypotenuse. And then we have our second ratio is cosine, which is the adjacent side divided by the hypotenuse. And then we have the tangent ratio, which is the opposite over the adjacent. So let's do some examples in order to solve these two triangles at the bottom. Right now, I'd ask you to pause the video and please take out your graphing calculator. In the first example, we have an angle which is 57, and we're told that the hypotenuse, the angle, the side opposite the right angle, is 11. So let's go ahead and label the side x that we're looking for. Because we're interested in angle 57, this side is going to be labeled the opposite side. So we're looking for the opposite side and we have the hypotenuse. So we're going to be using the trig ratio that deals with opposite and hypotenuse, and that would be sine. So sine of 57 is equal to the opposite x over the hypotenuse 11. Now, once we have an equation created, we can go ahead and solve this in numeric solve, or if you wanted to use some algebra, in this case, we would multiply both sides by 11. Now, super important, make sure your calculator is in degrees. Right now, my calculator, you notice it is in radians. So make sure if that is your case, that you change your mode into degrees. So I'm going to go into numeric solve, math up, and in numeric solve, I have on one side of the equal sign, so in one box is sine of 57, and in the other box, I have my fraction x over 11. And then I click on the graph button in order to solve, and I get that the value of x is equal to 9.23 if I round to 3 significant figures. Now we're going to go ahead and look at the second example. The second example, we're looking for an angle. And we know that the hypotenuse is 6. And this 4 is not the opposite side, right? This would be the opposite side. The 4 would be the adjacent side. So I'm looking for a trig ratio that involves hypotenuse and adjacent. That would be our cosine ratio. So I can create the equation cosine of x is equal to the adjacent 4 over the hypotenuse 6. We can also do this in our calculator. Even though we're looking for an angle, this is also going to work. So let's go ahead and replace my two boxes. In the first box, we have our cosine of x. And then in our second box, we have the fraction 4/6. And then I can go ahead and solve this. And I get that the angle is 48.2 degrees. Now that we reviewed right angle triangles, let's try a different example. Here we have a prism, and we're told that the diagram shows a cuboid. So cuboid is another word for a prism. And we have some dimensions. So we have 8, which is in the diagram, 6 in the diagram, and 16 in the diagram. Find the length of BC and give your answer correct to 3 significant figures. So BC, let's go ahead and see where that is in our diagram. So what we can do for this one is we want to try and create a right angle triangle in this three-dimensional shape, and we're going to use either our trig ratios or Pythagoras theorem in order to find our missing values. So for this question, there's a few ways that we can approach this question. One method that we can use is we can create the right angle triangle where we have from A to C and from A to B, and this creates a right angle triangle here, where we know that one of the legs is 8, and we're looking for the length of BC. So the length of AC, in order to find this one, there's another right angle triangle in here, which is CAF, right? So this triangle here is a right angle triangle where we have the 6 for the length of AF, and we have the 16 for the length of FC. So we can go ahead and use this triangle in order to find the length of AC first. And once we have AC, then we can go ahead and find out what is the length of BC. So I'm going to redraw my triangle here, the triangle FANC. So since I have two sides and I'm looking for the third side, I can use Pythagorean theorem here. So 16 squared is going to be equal to c squared plus the side AC squared. I can use numeric solve in order to solve this question, and we get that AC is going to be equal to 14.832. Now that we know AC, we can try and solve for what we're looking for, which is BC. So the right angle triangle involving BC, I can redraw this one. So again, we're looking for the third side of a right angle triangle, and we know two sides, so I can use my Pythagorean theorem. And then we solve and we get that x is equal to 12.489, and they say to round to 3 significant figures, so 12.5 would be the value for BC. Now part B, find the size of the angle between the line FC and the plane ABGH. Okay, I'm going to erase the colors I have on my diagram just to try and make more sense of what is happening. So let's first identify what is the line FC. So the line FC is the 16 that we have here, and the plane ABGF is this here. In order to find the angle between a line and a plane, what we have to do is create a right angle triangle so that the plane is cut as a transversal. So we want to cut through the entire plane. And then we're looking for the angle from F to B, so from F to B. And because we're interested in the line FC, we're going to need to connect B and C together. So we have this right angle triangle that's created. FBC is the angle we're looking for. And the size of the angle between FC and the plane is going to be this angle that I've labeled theta. So I'm going to redraw this triangle, and we're going to try and find theta. This triangle here, we have C, B, and F, and we're interested in theta. We know FC is 16, and B and the angle B at the bottom here is creating a 90-degree angle. We found in the question before the side of BC, which was 12.5, so I'm going to write that here. And now in order to solve for the missing angle, we have a right angle triangle. We have two sides in the right angle triangle, so we can use a trig ratio. Since I'm interested in this angle theta, these sides I have is my opposite side and the hypotenuse. So the trig ratio involving opposite and hypotenuse is going to be sine. So sine of theta is going to be equal to 12.5 divided by 16. And we get that our angle is equal to 51 point, and let's see what they want us to round. Give your answer correct to 1 decimal place. So 1 decimal place is going to be 51.4. A common application of right angle triangles is angles of elevation and depression. Angle of elevation means that from where you're looking, so from the horizon, you are going to be looking upward. So if we look at our example, from the observer, you're always starting by looking up straight in front of you from the horizon. And if you're looking up towards an airplane, for example, the angle of elevation will be created by the horizontal and the line of sight looking upwards. And for the angle of depression, very similar, but however, this time you are looking downwards. So starting for the horizontal, looking downwards, this is the angle created by the, for example, in the observer, you're still looking up ahead, and this time you would be looking down, let's say towards a boat, and this angle created by the horizontal and the line of sight looking down would be called the angle of depression. Let's do an example of this. We are told the angle of depression from the top of a cliff to a boat is 17 degrees. The boat is 450 from the shore. Draw a diagram to represent the situation and find the height of the cliff and give your answer rounded to the nearest meter. So we have a sea, somewhere like this. We have a boat that's floating in the sea. And we are told that there is a cliff. So I'm going to draw my cliff somewhere like this. And we are at the very top of the cliff. And we are, angle of depression, we are looking down towards the boat. So since we're looking down towards the boat, the angle of depression is not this angle here, which is a common mistake. When we're looking at angle of depression, remember, we need to start looking straight ahead, and the angle created by the horizontal and looking at our object is our angle of depression. So this is our 17 degrees. And we have a right angle that's created by the cliff joining the sea here. And we're asked to find the height of the cliff. So we're looking for this here. So we now have a right angle triangle. Let me redraw a triangle so that we can see it clearly. And we have this is x. And oh, I forgot the 400. 400 is the boat is 450 meters from the shore. So the shore is where we have the cliff is stopping. So the boat is 450 meters from the shore. This 17 degrees, we can see it up here. That means that in order to find the angle within our triangle, we can subtract 90, right? So this angle right here, I can find by doing 90 minus 17, and we're going to get the angle of 73. So this is the angle I have here. So using this right angle triangle, now that we have an angle, we know that the opposite side is 450, and we are looking for the adjacent side. So the tangent ratio is going to be what we want to use. Tangent of 73 is equal to opposite 450 over adjacent x. Use your numeric solve or solve this algebraically, and you should get that x is equal to 137.579, and they want us to round to the nearest meter, so that means x is equal to 138. Now let's look at example 2. Example 2, we have from his studio window at point A, which is 6.5 meters above the ground. 6.5 meters above the ground is identified in our diagram from point A to point E, meaning that our ground is the line ED. Tom views the top and the base of the building on the opposite side of the street. The angle of elevation and depression of the top and the base of the building are 55 and 18 respectively. Find the height of the building he is viewing. Give your answer to 2 decimal places. So first we have the angle of elevation, and then we have information about the angle of depression. And we're told if we read this sentence, the respectively part is super important because we have 2 pieces of information. So first, let's go ahead and highlight in green all the angle of elevation sections. The angle of elevation of the top of the building is 55, while the angle of depression of the base of the building is 18. And the reason why I'm alternating the colors is because of this respectively, meaning that you have 2 pieces of information and they're following each other as such. So let's go ahead and identify this in my diagram. Let's first start with the angle of elevation. So from his point of observation A, he sees the top of the building. And we always need to compare it to the horizontal line created from where he's starting to see. So our angle of elevation is going to be 55. And while if we look at our angle of depression, always starting from where we're looking down towards the bottom of the building. And the angle of depression is always using the horizontal as well. And where we're looking down, and this angle here is 18. Now, when we're dealing with angle of depression and elevation questions, we're always going to be using right angle triangles. So the right angle is created by the building and the ground. So we are looking for the distance of C all the way to D. What we can do is we can first find out what is the length CB, so just this side of the wall, and using the top triangle, and then using, let's see, gray, I can find BD, right? And this is going to be using the second triangle. So let's go ahead and find out our X and Y. We can't really see the gray well. So let's start with the first part. So using the top triangle ACB, we can find the missing part of the wall. So we have the angle 55. We are looking for the opposite side. Now, we're looking for the opposite side, and we actually don't know any other information in this triangle. So maybe starting with this triangle isn't the best approach. Let's go ahead and look at the second triangle and see what we have. In the second triangle, we have more information because we have the information that we have 6.5, which is here, which corresponds to the measurement y. So 6.5, if I redraw this triangle. So now using our triangle, we can find out what is this missing side, which is going to be the same one used in the other blue triangle. Let's go ahead and find that. In this triangle, we're using the angle 18, which means we have the opposite side, which is 6.5, and we're looking for the adjacent side. So therefore, we're going to use the tangent ratio. The tangent of 18 is equal to opposite over the adjacent. Putting this into numeric solve, we get that the adjacent is equal to 20. Therefore, I can use the second triangle. Let me draw the second triangle such that I have a right angle. The bottom is 20. The angle of elevation we said was 55. And we're looking for the opposite side. So again, I have opposite and adjacent. So I can use the tangent ratio. So x over 20. Putting this into numeric solve, we get that x is equal to 28.6. Therefore, the height of the building is going to be our 28.6 plus 6.5. So we get that the building is 35.1.